Hi everyone, in this video for grade 9 we have 2.5, which is about factoring by using special identities. On page 68 from the book. In this lesson we have two different roles, two different kind of questions, which is perfect square trinomial. Trinomial we mean that it's three terms, 1, 2, 3 terms, and the first and the last are perfect square. Difference of two square, we mean difference means there's minus between. Difference of two squares means it is two parts and both of them square. Something power 2, something power 2. So this is difference of two squares, which is two parts. This is perfect square trinomial, which would be three parts. Be very careful about the result of that. A minus b to the power of 2 in bracket and a power 2 minus b power 2. They are totally different. This is perfect square trinomial. This is difference of two square. An example about the perfect square trinomial, like this one. X plus 5 to the power of 2 means x plus 5 multiply x plus 5. We do multiplications as we did before in the other examples and in the other lessons. We do this multiplication, we will get that x power 2 plus 10x plus 25. If you see the ends, they are perfect. 25, 64, 25 is from 5, 64 is from 8, and you see they are perfect. The beginning and the ending are perfect. And three terms, perfect square trinomial. Always in the perfect square trinomial, the last sign, this one, the last one, always would be plus, positive, always. Always must be positive in perfect square trinomial. But this one, it's possible to be positive or negative. It will be one of them according to the sign inside the bracket from the beginning. If it's plus, that will be plus. If it is minus, that will be minus. And in the factors, if you factor that to the other form, if it gives you the answer like that, x power 2 plus 10x plus 25, factor that expression. You think about the square root of that, which is x, and the square root of that, which is 5. Then it will be x 5. What between them? According to the first sign always. It will be x plus 5 power 2. Or x plus 5, x plus 5. This one, you think about the square root of this one, which is x. The square root of this one is 8. X, 8, and between them must be minus. X minus 8 power 2. Like this. Then let's see the examples. The examples for the first one, for the first example, determine if it's a perfect square. If so, factor. If it's not, explain. This is 12x. The first one, x power 2 minus 12x plus 36. You think about, is it perfect? Yes. Is it perfect? Yes, it's x power 2 minus 12x plus 36. We said we think about the square root of this one, which is x, the square root of this one, which is 6, and between them must be minus x minus 6 power 2. Now, to know that your answer is correct or not, always you need to check for yourself. Check that x minus 6 multiplied by x minus 6. Is it the same result or not? If you get that result, it means it's correct. If you didn't get that, it means you did a mistake. This is checking this red one in the answer of the questions. We don't need it as a part of the answers of the for the test, for the exams, but for yourself you need it too much. X multiply x is x power 2, x multiply negative 6 is negative 6x, then negative 6 multiply x is negative 6x, negative 6 multiply negative 6 is plus 36. We have like terms, negative 6x, negative 6x would be negative 12x plus 36. Is it x power 2 minus 12x plus 36. Yes, that's it. This is correct. The other one, is it perfect? Yes, it is 2x power 2. We can write that. It is 2 power 2, it's x power 2. And this is perfect, which is 3 power 2. It must be perfect. Something, all of them must be power 2. This power is only for the x now. But 4 is also perfect, which is 2 power 2. So this is 2 power 2 x power 2. Like that. And this is 3 power 2. Now, if you think about the square root of these, you will get 2x, 3, square root of 9 is 3, and between them must be minus. Always power 2. To check it, this is our answer. Let's see if it's correct or not. We will multiply them by each other, which would be 2x minus 3, 2x minus 3. 2x multiply 2x will be 4x power 2. 2x multiply negative 3, it will be negative 6x. Negative 3 multiplied by 2x, it will be negative 6x again. Negative 3 multiply negative 3 would be plus 9. Then for the next step we have like terms, negative 6x, negative 6x. We can do them together, which would be negative 12x plus 9. We check if it's the result that we had from the beginning or not. If it is, we can know that our answer was correct. That's it. This is our answer, 2x minus 3 power 2. That expression came from 2x minus 3 multiplied by itself, multiplied by 2x minus 3. And this one came from x minus 6 multiplied by x minus 6. Then for the other examples about difference of two squares, in the difference of two squares, at first you must know that if it's a perfect difference of two squares or not. If it is, you must factor. If it's not difference of two squares, you must explain why it is. In difference of two squares, we said in between we must have minus, and these two must both of them be something power 2. This is x power 2 and this is 9 power 2. Yes, both of them, it's fine. In this case, when it's two parts, it's difference of two squares. So you open two brackets, always you do like that for the difference of two squares for two terms, which is both of them perfect, between them minus. This one is x power 2, we write xx. This one is 81, which is 9. The sign would be one of them minus, one of them plus. You can put plus, minus, or minus, plus, as you like. Both of them correct. Now if you multiply these two by each other to check your answer, you see x multiply x is x power 2. X multiply positive 9 would be plus 9x, then negative 9x, then negative 81. Now if you see, we have like terms which is plus 9x minus 9x. These two together, plus 9x minus 9x, would be 0. Plus 9 minus 9 would be 0. So the remaining is what? X power 2 minus 81. Is it the same result that we had from the beginning? You see, yes, it is. So this is our answer, which is x minus 9, x plus 9. For the next one, which is the last example about the difference of two squares, let's see. Is it something power 2? Can we write them as power 2, something power 2? It is 4. 4 is 2 power 2. And it's p power 4, we can write as this one, 2 power 2. This one, we can write as p power 2, power 2. It's possible, yes. This 2, p power 2, all of them power 2. Minus, this is 4 power 2, this is m power 2. You open two brackets, then it is 2p power 2. Be careful about writing these powers. You don't write these two powers because we just show that they came from something power 2. Square root of that is 2. Square root of that is p power 2. So for this one, 2p power 2 for this one, 2p power 2 for this one. This is 16m power 2. It means 4m for this one, 4m for this one. One of them must be minus, one of them must be plus always. This is our answer. Now we check to see that if it's correct or not. 2p power 2 multiplied 2p power 2 would be 4p power 4. 2p power 2 multiplied by 4m would be plus 8p power 2m. Then negative 4m multiplied by 2p power 2, it would be negative 8p power 2m. Then negative 4m multiplied by negative 4m would be negative 16m power 2. Again, this time we have like terms. This is plus 8p power 2m, p power 2m. This is plus 8, this is minus 8. Plus and minus for the same number will be 0. It is 0. But be careful, in the perfect trinomials, like in the first example, we got minus 6, minus 6. Minus 6, minus 6 would be minus 12. But this is plus, this is minus. They will make them each other 0 cancelled. That's it. Now the result, the final result for this one would be 4p power 2 minus 16m power 2. And this is the same as we had before in the beginning. It means our answer is correct, and that's all about the two identities that we have: perfect trinomial and difference of two squares. Thanks for watching. Have a good day.